Okay, we're on to determining equations, again given a function. In this case, we are given some kind of sinusoidal function, and it's very interesting because we're actually not given one full cycle. In the picture over here, we are given one, but it's let's just say it's not a discernible full cycle. Okay, we don't really know where the beginning and end points are, but it's it's going to be something like over here and like that. Okay, usually we're used to starting it from the middle or the top or the bottom. In this case, it's just not so clear cut. And if you look closely here at the end, it's like, well, where does that finish? Does it, is it 3.4, 3.3? Who knows, right? So we're going to have to use a little bit of ingenuity to determine some properties. Let's start off with, I guess, the middle of this graph. Well, the height, the topmost point is 4, the bottommost is 0, so the amplitude is going to be 2. Again, the distance from the middle to the top, that's 2. The k value, okay, which is the shift up or down, is also going to be 2. As you can see, this has been shifted up 2 units. The period. Okay, well, let's think about this for a moment. What can we do? Never mind, there actually is a full period in here. If we go to negative 270 to the top, to 90, to 270, to 450, we do get a full period. And it is visible. Okay, so in this case, I just saw that now, 270 negative to 450. So you can do 450 minus negative 270. And that is going to give us, let's see, 550, 650, will give us 720 degrees. So that's our period, which means our b value is going to be 360 divided by 720, which is 1 over 2. Okay, so let's start determining our functions. Beginning with sine, f of x equals, the amplitude is 2, times sine, open bracket, and we're going to have a b value of 1/2 x minus, we're going to leave that blank for now, and then a plus 2 for our k value. So if we're looking at sine, the original, sine initially starts in the middle. Oops, gotta get a bit more than this. Sine starts in the middle. Let's just do one smooth curve. Sine goes from the middle and then up. So in this case, we're moving it back or to the left 270 degrees, which means I'm going to have a plus 270 degrees here. Okay, same thing, this time for negative sine. I'm going to take my equation, make a little bit of a space here, put in negative, and instead of plus 270, so negative sine is going to go from the middle down first. So this is the original negative sine, and I'm going to be moving it over to the side. How much? Well, that middle point there is about 90 degrees, which means my shift will be minus 90. Next, doing the same thing for cosine. I'm going to move this over to the side. I'm going to have f of x equals 2 times cosine 1/2 x, whatever that is, plus 2. And I'm going to get this. Do the same thing here. Just leave a little bit of a space at the front for the minus. What happens? So cosine starts from the top and then goes down. So that's where my original graph would be, and I'm shifting it back 90 degrees. So my shift will be x plus 90 degrees. For negative cosine, I'm starting from the bottom. So it's like taking the graph over here and shifting it over 270 degrees. So I'll have a minus 270 degrees. By the way, if you haven't noticed, when you take the sum of the absolute values of these phase shifts for both cosine and sine, okay, sine, the positive and the negative, the cosine, the positive and the negative, they add up to 360. This and this together is 360. This and this together is also 360. Is it always the case? I'll let you maybe do some investigation into whether that's true or not. Maybe look back at some old examples where you had to graph both, you had to come up with the equation of both the sine and negative sine, or the cosine and negative cosine, and see if the horizontal the horizontal shifts or the phase shifts add up to 180, 360, just an absolute value.